Hello, everybody. We are doing the 2011 Form A number 6. Let's just get started. So for part A, what I'm about to write is actually going to be your conclusion, what you're trying to show, but I'm just going to, let me put it in I'll box it after. This, actually, I'm going to do this at the bottom. That's a great idea, Sheeta. So at the end, my conclusion should be this. Yeah, here's what I'm trying to get to. F is continuous at x equals 0 because, and here's your reason. Here's what you're trying to get to. You're trying to show the limit as x approaches 0 from the left of your function equals the limit as x approaches 0 from the right of your function equals a function at that point. So that's my conclusion, what I want to get to. So to get there, I need to show each of these limits separately. So that limit, and that function, I have to evaluate all three of those. So let's start with the first one. I want to find the limit as x approaches 0 from the left of f of x. Well, if I look to the left of 0, that is the function. So technically, I'm finding the limit as x approaches 0 from the left of 1 minus 2 sine x. And how do I find this limit? Well, since this function is continuous, we know it's continuous. And if it's continuous, the limit must equal the value at the point. That's what we just stated here. If the limit equals the value at the point, it is continuous. So going backwards, so if it's continuous, then the limit equals the value at the point. So all we're going to do is plug in 0. And we get -1. Then we're going to do that same procedure from the right. The limit as x approaches 0 from the right of f of x. Now, as we're approaching from the right, that's to the right, so it's e to the negative 4x. And for the same reasons, to find this limit, it's just plug in 0. Whoopsie daisies. And that gets us e to the 0, which is 1. I messed up somewhere. The first one should have been 1. Sorry, Charlie. Oh, wow. My brain is lame-o. I can't believe I did that. The sign of 0 is 0. So 1 minus 0 is just 1. Wow. That's embarrassing, Yoshida. All right. So the last one is f is 0. But again, we look to f at 0. That's what the function is at 0. So that's going to be the function with a 0 there, which is 1. That's just like the limit from the left. So we've shown that the limit from the left, the limit from the right, and at 0, they're all equal to 1. Now we can write this conclusion. Therefore, f is continuous at 0 because the limit from the left equals limit from the right equals the value at that 0. So we're done. Part A is finito. We are done. Now we're going to part B. So we want to write the function, the derivative of f. Okay, so for x less than 0, I'll tell you why we don't do equals here. Even though there's equals there, we're not going to put equals here, and I'll explain why. But the derivative of 1 is 0. The derivative of -2 sine x is just -2 cos x. So we're done with that. And then to the right of 0, we're just going to take the derivative of e to the -4x. But that's not x. If it was just an x, the derivative is easy. It's just itself. But since that's a box, the derivative will be e to the box. It's a function when I say box. It's e to the function times the derivative of the function, which is negative 4. So that is the derivative. Now, why do we not have an equal sign right here when the original had it, the function? Because at 0, those two functions meet. And the slope from the left does not equal the slope from the right. This is the slope of the tangent line. That is the slope of the tangent line. When I plug in 0 for the top one, I'm going to get negative, or actually, yeah, negative 2. I plug in 0 for the bottom one, I get negative 4. So the slope left and the slope from the right are different. Therefore, there's a sharp point. Therefore, the derivative does not exist. Therefore, I don't have an equal... Whoa, that wasn't supposed to happen. I don't have an equal sign right here because the derivative doesn't exist, so I shouldn't say it exists. All right, we're not done. Again, always reread the question. So we did that part. Now we have to find the value for which the derivative is negative 3. All right, let's take a look at this. So this is the derivative. So we're going to have to set, and this is the derivative, sorry, both those are. So we have to set each of those equal to negative 3. Now, the first one, clearly that's never going to happen because the biggest cosine can be is 1. It can't be bigger than that. So this times this will never equal 3. So this has no solution. So therefore, we need to look at the other one. So we're going to just use algebra. Divide both sides by negative 4. And then I am running out of space again. I'll get e to the negative 4x equals 3/4. To get rid of the e, I have to ln both sides. This is getting messy, sorry. I have to ln both sides, so ln the left, ln the right. Those will cancel. And then divide both sides by negative 4. And I get my answer. X is ln of 3/4 over negative 4. Done. That is part B. Let's go on to C. All right, average value. You have to know the average value of any function as you integrate that function. And then you divide by the width. And that's what we have to do. So if we look at this function, it consists of two different functions. So we have to break this integral into two different parts. The left half and the right half. The left half is going to be 1 minus 2 sine x. And the right half is going to be e to the negative 4x. All right, so the left half, which is this part, we have to find the antiderivative of that. That's pretty straightforward. That's going to be x and minus cos x, which is going to make that minus 2 when we take the derivative. So that all matches up. Then this part, here's where it gets a little weird. We need to do u sub. So du will be negative 4 dx. Now, do we have negative 4 dx? We don't. So I'm going to put a negative 4 there and a negative 1 over 4 in front. So now we have what we're looking for. So all of that's going to be du, and all of that's going to be u. One more thing that we have to consider. These are values of x to match up the dx. But our new function is going to be du. So we need to change those x's into u's. So when x is 0, u will be negative 4 times 0, or u is 0. When x is 1, u will be negative 4 times 1, u will be negative 4. So all that gets placed here, negative 1/4 integral from 0 to negative 4, e to the u du. So I just subbed everything out. Then, let me go to the next line. I'll go ahead and sub this part in. So I'm going to get 0 plus 2, cos 0 is 1, so it's going to be 2, minus, then I'm going to plug in the negative 1. And if I plug this here, ooh, that I cannot do in my head. I cannot. I'm not that smart. So we have to leave that because it's not a calculator problem. Then I need to do this side. Whoops, let me undo that. I realized I shouldn't have done that. So the antiderivative of e to the u is just e to the u. So I'm going to get and that's going to go from 0 to negative 4. So if I plug those in, that should give me my answer. So let me simplify this first one. 2 plus 1, I'm going to get 3 plus 2 cosine of negative 1 plus, now I'm going to plug in the negative 4 and then plug in the 0. Which is going to get us all of this. Actually, minus. No, yeah, minus. And that's going to be plus on this one. Now, a note. I probably should have said this. You should stop right there. You are finished. Don't have to simplify. If you simplify incorrectly, you lose a point you already had, so please do not simplify this. I'm just doing this part because some of you I don't know, can't help yourself. Oh no! Yoshida messed up. Yoshida forgot to divide all these by 2. Yoshida divide by 2. Oh man, it's going to get ugly. This is all over 2. This is all over 2. Nice save, huh? This is all over 2. This is all over 2. Yikes. And then you can simplify that further, but I am out of room. I won't go any further, but yeah, I'm done. That's it. That's kind of ugly, but hopefully this was helpful. On to the next problem.